Welcome back to the Greater Essex County District School Board calendar, where we are exploring the fundamentals of mathematics. Each month, we are diving into a big idea from the Ministry of Education's Focusing on the Fundamentals of Math, a Teacher's Guide, and in particular, the table summarizing curriculum expectations from our current Ontario mathematics curriculum that has always been and will continue to be fundamental for developing students' understanding and proficiency in mathematics. Over the next few videos, we'll explore developing mental math skills in order to work towards mastering math facts. In this video, we will extend our learning from addition and subtraction structures to dive deeper into more complex addition and subtraction scenarios that will reveal how the operations are related. Let's dive right into a scenario where we have 12 cookies, and some of those cookies are eaten, leaving 8 left over. The question is, how many cookies were eaten? As we experienced in previous videos, the answer to this problem might be obvious to us, but what may not be obvious is exactly what is happening in this problem. What makes this problem so challenging for children is the fact that while this is an active subtraction problem where we are removing cookies from the total, what we are given is the start, or the minuend, and the result, or the difference, and we are missing the change, or what we call the subtrahend, the quantity that we are subtracting. This missing subtrahend essentially gives students a scenario where some algebraic thinking is introduced, this idea that we have a missing value in an equation. This is really complex thinking for young children. However, students are doing this in the primary grades, often without realizing it. If students are building a conceptual understanding of addition and subtraction by utilizing mathematical models like the visual we see on the screen to the left, and eventually utilizing number lines, students can then utilize some of the strategies they've developed using these mathematical models, such as counting on, for example. Here we count up from 8 to 12, or counting back from 12 to 8, giving us a difference of 4. In this particular case, that value of 4 is what was subtracted from 12 initially. And over time, students will be introduced to the balance model to actually use algebraic thinking to solve this equation. Here, we can see 12 on the left side of the balance, and you'll notice that it's weighed down. And we know that the other side only has 8 cookies on it. So the question is, how many more cookies do we really need on the right side? So students can actually access this task thinking through addition as well. And this helps us to show that there's an intrinsic relationship between addition and subtraction. So let's take a look at what we can do here. If we were to remove a single cookie from either side of the scale, then the scale would go out of balance. So for every cookie I remove on one side, I have to remove the same number of cookies on the left. So if we were to actually remove 8 cookies from the right and 8 cookies from the left, we'll actually see that all that's left on the scale is actually 4 cookies on the left. And since it's still in balance, we know that the missing value, the missing number of cookies, must be 4. So this is just one other way that we could solve this particular problem. Let's look at another example. Here we have a scenario with 3 apples. And we actually need 11 apples. So the question is saying, how many more apples do we need? Again, we're looking at the difference through comparison. So again, while this is a scenario that might be obvious to you or I looking at this model, it's not so obvious for students until they build the model. So we can see here that the difference is going to be 8 apples. What we may not see is that this is actually a scenario that we can access through subtraction. However, it's oftentimes additive thinking that students are using to solve this problem. 3 apples plus some other quantity of apples will give us 11 apples. So while this is a subtraction problem with a missing addend, often students are accessing it through addition. So this makes this problem very, very challenging for students. But again, if we use our visual and concrete models, for example, the visual on the left side of the screen, or if we use another visual model like the number line, we'll see that the difference between 3 apples and 11 apples is, by counting up or counting backwards, going to be 8, a difference of 8. And again, we can also access this subtraction problem with a missing addend in this case through the balance model, where we see that there's 11 apples on the right side of the scale, but we're out of balance, as you can imagine. Let's go ahead and put our 3 apples on the left side of the scale. Notice the scale didn't move because we're still out of balance. There's a certain number of apples that we need to add to the left side of the scale in order to make this equation true or make this equation balanced. Like we did before, we can actually start removing apples on either side, an equal number of apples on either side. On the left side, I can see there are 3 apples, and I can remove those from the left and the right. And using the commutative property and the associative property, as we learned a few videos back, we can actually see that the result must be that there are 8 apples needed. So under that blue box, there should be 8 apples, and there are. In this video, we explored some of how we can develop mental math skills for mastery through relating addition and subtraction. I hope you'll join us in the next video where we're going to continue unpacking the fundamentals of mathematics through the Greater Essex County District School Board calendar. We'll see you there.